For lesson 24, it is the elimination method. And here were our ways of solving system of equations before. Graphing. We had Cramer's rule, as well as our substitution. Fourth and final one today will be the elimination method. There's our two equations. 15 is equal to 3x minus 2. X is equal to negative 11 minus 2y. When we do the elimination method, we like to be in standard form. So let's review that a little bit. Standard form, we simply want to get our variables on the left side of the equation, or equal sign, and then get the constant over to the right. And if we look at example number 1, the very first equation, 15 is equal to 3x minus 2y, okay, we have the variables on one side and the constant on the other. Well, let's just go ahead and flip this thing now. 3x minus 2y, that's going to be equal to 15. And notice equation number 2 has a little bit of work to do for us. I see that I have the x over here on the left, but I need to bring this negative 2y over. So I need to simply add 2y to both sides. Everybody okay with that idea? Both the equations are in standard form, so now we can go ahead and do our elimination process. The game is simple. We want to eliminate one of the variables. Hence the reason why we call it the elimination method. It does not matter whether you go for x or y. As I look at this one, I would say the y variable is going to be the easiest to eliminate because, if I look at this thing, we're going to add straight up and down. Negative 2 plus 2, the y's cancel out on it already, don't they? Without any work at all. So 3 and 1 will get us 4x. Negative 2y plus 2y will get us 0. That's what we wanted. 15 minus 11. If you would like to view it as 15 plus negative 11, it's the same thing. Divide by 4. X is equal to 1. And again, we got to plug it back in to solve for y. I would go back to one of these. So it doesn't matter. 15 is equal to 3 times 1 minus 2y. Subtract 3. Or again, the order pair. There it is. Let's review one more time. Would this system be consistent or inconsistent? Consistent because we have at least one, and then independent or dependent? Independent because one unique. Okay, we're looking at example 2 now. 3/4 x is equal to 3y, and 15 plus 7y is equal to 3x. Okay, this is kind of different. As we look at this, we're thinking maybe substitution would be better, but let's go ahead and solve it using the elimination method. If I look at this first one, 3/4 x is equal to 3y. Well, we still need to get it in standard form, which means I need to get the variables over to the left. So I need to bring this 3y over. Therefore, subtract 3y to both sides. What am I left with on the right-hand side now? 0. So set it equal to 0. If we take a look at this one, we need to move the 3x over, the 15 over to the right. So when I bring the 3x over, I need to subtract 3x to both sides. 7 needs to stay there. Subtract 15. Therefore, it's negative 15. We okay with that idea? As you do it, you'll get better with it. And again, the game is we need to eliminate one of the variables. If we look at the x's, there's no elimination taking place there. And then if we look at the y's, there's no elimination there either. Okay. So, now what do we do? Abby?
I moved instead of moving the 3 over and then the 15, I moved the 7y over. So it was 3x minus 7y equals 15.
And that's perfectly fine too. Let's talk about that. So this is what Abby came up with. Right? Why is this the same as this one? Well, we are actually going to use a property that we're going to use to solve this one, our multiplication property of equality, which states if I multiply both sides of the equation by the same amount, it's still balanced, right? You agree that 3 is equal to 3? So now if I want to multiply it by, say, my favorite number 4, is it still true? Yeah. 12 is still equal to 12. So what's the number that we want to multiply by here? Well, we could multiply both sides by -1. And notice now this one's exactly the same as that. Okay. So here we are again. Which variable do you suppose we want to get rid of?
X.
Yeah, let's go ahead and try and get rid of x. And with this, we actually don't, we could say we don't like the fractions, so we could get rid of those. So if I want to get rid of this fraction, what would I multiply both sides of the equation by? Well, it's whatever your denominator is, which would be 4. So let's do this. When I take 4 times the x, what do I get? Well, the 4's would cancel, so we get that 3x. Distribute the 4. 4 times 3 is -12. And 0 times 4 is still going to get us 0. And if we take it our two newly created equations, okay, they're still balanced. They're still the same equation. We've just modified them a little bit. But if we look at that, notice we actually killed 2 birds with 1 stone here. Not only did we eliminate the fraction, but now we also created a cancellation to take place. +3 and -3 will go away. There's our elimination. -12 plus a +7 will get us -5y. And then I have a -15 down there. And now the final step, plug it back in and solve. I would maybe go with the second one just to stay away from the fractions. So 15 plus 7y, which is 3, is equal to 3x. 15 plus 21. Let's do one more. Infinitely many solutions versus no solutions. We can still have our 3 scenarios. So we got to be able to identify it here. 2x minus y is equal to 3. -6x plus 3y is equal to -9. If we just write these, we notice that neither of the variables cancel out for us right away. So we need to multiply by a value again. 3? And why do you say 3?
Because then 2x minus y equals 3. You could cancel out the x's.
So you're looking to cancel out the x's, right? Okay, it doesn't matter, either one. Addie just realizes, hey, if I multiply this 2 by a 3, 6 and -6, I'll get my cancellation. So let's do that. 3, 3. 6x minus 3y is equal to 9. So sure enough, our x's cancel out. There they go. But what happens to our y's?
They cancel out.
Yeah, they also cancel out, right? So really what I have here is I have 0 plus 0 is equal to, what do I get here? 0. Well, 0 and 0 is 0. So again, the variable goes away and students will panic. Don't. Okay, it'll happen every once in a while. Now we need to ask ourselves, true or false statement here?
True.
It is a true statement. Therefore, what do I put for an answer? Infinitely many or just simply many solutions. Either one. Let me ask you this. If I get the statement 7 is equal to -9, what do I write?
No solution.
No solutions. Okay? It's the same thing that we used with for substitution.